Lesson 4-5, Trigonometric functions of any angle. Alright, here is a unit circle, only it's not a unit circle anymore. Our radius is now not 1, it's r. And so what we could do is with any angle is we could draw a right triangle. And our central angle here would be something, let's call it alpha. And then, since it's a right triangle, we could find things like sine. Sine is opposite over hypotenuse, or y over r, and cosecant is the reciprocal, r over y. Cosine is x over r, adjacent over hypotenuse. And tangent is opposite over adjacent, y over x. Now you're saying, but that's alpha, not theta. But remember, with the unit circle, the symmetry. So because of the symmetry, it works for alpha and theta at the same time. If you want to find the radius and you know x and y, you can use the Pythagorean theorem to find the radius. So let's try an example. Let -2, 3 be a point on the terminal side of angle theta. Find sine, cosine, and tangent. All right, well, -2, 3 is right there. So if we draw our right triangle here, the x is -2, the y is 3. We need to find the radius. Use the Pythagorean theorem. So it's -2 squared plus 3 squared, which is 4 and 9, so it's the square root of 13. So sine is y over r. Y was 3, r is the square root of 13. Of course, we have to rationalize that. So it'll be 3 square root of 13 over 13. Cosine is x over r. So that'd be x is -2 over square root of 13. Rationalize that, so you get -2 square root of 13 over 13. And tangent is y over x, so that is 3 over -2, or -3/2. Alright, given that sine is 4/5 and tangent's less than 0, find cosine and cosecant. Well, to do that, we need to look at what trig functions are positive in each quadrant. So you can see in quadrant 1, they're all positive. And it's all positive because both the x and the y are positive. But in quadrant 2, the x is negative while the y is positive. So the only things positive are the things that are y, and r is always positive, so the things that are just y and r. So that's sine and cosecant. Quadrant 3, both the x and the y are negative. So the only things that are positive would be the ones where you'd have negative and a negative to cancel out. So that'd be tangent, which is y over x, or cotangent, x over y. In quadrant 4, the x is positive and the y is negative, so to be positive, it just has to have the x and r. So cosine. Way to remember this is all students take classes to remember what's positive in each quadrant. Well, in our problem, sine is positive. So sine is positive. It's either quadrant 1 or 2. But tangent is negative. Well, in quadrant 1, everything's positive. So to be sine positive and tangent negative, we have to be in quadrant 2. All right, sine is y over r. So we know, let's draw a new one here. We know the y is 4, and we know the r is 5. So we can use the Pythagorean theorem to find x. So x squared is 9. Now when you do this, technically we have to take a square root while we're solving, so it's plus and minus. So the x over here, it's over here, is negative, so it's actually going to be a negative 3. So cosine is x over r, so it'd be negative 3 over 5. And cosecant is the reciprocal of sine, so it is r over y, so that is 5 over 4. Let's try another example. Let's evaluate sine of pi. Well, having a circle, and so these points are from the unit circle. Sine is y over r. So if I'm using this point, what's r? Well, the distance between 0, 0 and negative 1, 0 is 1. Feel free to use the distance formula if you want. The y is 0, the r is 1, 0 over 1 is 0. So sine of pi is 0. How about tangent of pi over 2? Well, that's up here. Tangent is y over x. The y is 1, the x is 0. You can't divide by 0, so it is undefined. So if you get an angle that's on one of the axes, you just use the coordinates from the unit circle. A useful idea for finding the trig functions of any angle is using the reference angle, which is an angle between the terminal side and the nearest x-axis, which always gives you some angle between 0 and pi over 2, or between 0 and 90 degrees. Let's find the reference angle for 5 pi over 4. So here's 5 pi over 4. The reference angle goes to the nearest x-axis, so right there. Well, that angle on the left side of the x-axis is pi. So to find the reference angle, we just need to subtract. So 5 pi over 4 minus pi. Of course, we need a common denominator, so that would be the same as 4 pi over 4. So when you subtract 5 pi over 4 minus 4 pi over 4 is 1 pi over 4. So that is our reference angle. Let's try another one. 5 pi over 3. So that would be right there. And so our reference angle goes to the x-axis. So we have a choice of calling that 0 or 2 pi. Well, we're closer to 2 pi, so we'll use the 2 pi. And we need to subtract. Now when you subtract, do the larger one minus the smaller one. So it'll be 2 pi minus the 5 pi over 3. Of course, we need a common denominator, so it'll multiply by 3 over 3. So I have 6 pi over 3 minus 5 pi over 3 is 1 pi over 3. So notice both of those are between 0 and pi over 2, so it's like they're in the first quadrant. So really, if you just memorize everything for the first quadrant and use reference angles, and all you'd have to do then is remember signs for finding any of these angles. So let's use a reference angle to evaluate cosine of 5 pi over 3. Well, we just found the reference angle in the last example, but let's run through it again. That's 5 pi over 3. Reference angle goes to the nearest x-axis, which could be 0 or 2 pi in this case. And we are closer to the 2 pi, so we'll subtract the 2 pi and the 5 pi over 3. Get a common denominator. And we get 1 pi over 3 for our reference angle. So then what we'll do is we'll use the reference angle and the unit circle. Okay, so cosine of pi over 3 is here. That point is 1/2 square root of 3 over 2. Cosine is the x. So that is 1/2. Now we're in quadrant 4. The original one is in quadrant 4. All students take classes. Cosine. Cosine is positive in quadrant 4. Therefore, our answer is positive 1/2. Let's try another one. Sine of 150 degrees. All right, let's start by finding our reference angle. 150 degrees is here. That's our reference angle to the nearest x-axis, which is the 180 degrees. So our reference angle is just subtracting those, so you get 30 degrees. So we could find sine of 30 degrees. Well, 30 degrees is here. That coordinate is square root of 3 over 2, comma 1/2. Sine is the y, so it's 1/2. Now we have to check for positives and negatives with the original angle. All students take classes. We're here in quadrant 2, which is sine, so sine is positive. Therefore, our answer is positive 1/2. If we were in quadrant 3 or quadrant 4 with the same reference angle, it would be negative because sine is only positive in quadrants 1 or 2. All right, let's try using a reference angle for tangent of 11 pi over 6. Now I realize these are all on the unit circle. We could just use that, but we're practicing with the easy ones so you can do it when you get harder ones. 11 pi over 6 is here. So that's our reference angle, always to the x-axis. So that would reference with 2 pi. So subtract the 2 pi and the 11 pi over 6. Get a common denominator. Looks like we get 1 pi over 6. So we're going to go and find tangent of 1 pi over 6. Pi over 6 is here. Its coordinate is square root of 3 over 2, comma 1/2. Tangent is y over x, so it is 1/2 over the square root of 3 over 2. We divide by multiplying by the reciprocal. So it's 1 over the square root of 3. Oh, but we have to rationalize that. So it's the square root of 3 over 3. Now let's check the sine of the original angle. All students take classes. So we're here in quadrant 4, which is cosine. Oh, we're not doing cosine, we're doing tangent. Therefore it is negative. So it's negative square root of 3 over 3. All right, let's make it a little more interesting. So let theta be an angle in quadrant 3 such that sine is negative 5 over 13. Well, it says we're in quadrant 3. Sine is the opposite, or the y, over the hypotenuse, or r. So the y is -5, the r is 13. Well, we can use our Pythagorean theorem to find the x. And when we take our square root, don't forget the plus and minus. And so we have to decide, should this be a positive 12 or a negative 12? Well, we're heading towards the left, so it's negative. All right, so now secant is r over x. So that would be 13 over -12, or -12/13. 13/12. Tangent, let's find tangent of that. Tangent is y over x. The y is -5, the x is -12. The negatives cancel, so tangent is 5/12.